Dear students, here we will consider the concept of the mass. That what is the mass and how we can define the mass. Okay, for this, let's suppose we have two different ball. And first, let this one is we have two different ball. And let's suppose this is a basketball. This ball is basketball. And then we have another ball, and this is larger in mass, and let's suppose this is heavier and this is larger in mass, and this ball is bowling ball, and this is bowling ball. This one is the basketball and this one is the bowling ball. And now, and the basketball is the lighter, has the less mass as compared to the bowling ball, which has more mass. It has more mass, and therefore it has more inertia. It has more inertia, and therefore it will be the more resistant. More resistance to the change in velocity. To the change in its velocity. Okay, so if you have the two ball, one is the basketball and one is the bowling ball. Now you have the different question, you can have the different question in your mind, and first question is can be that which ball more likely to keep moving. Question 1 is which ball more likely to keep moving. Okay, when you try to catch it. When you try to catch it. So this is your first question, and second question, it can be like that. Which ball has the more tendency? Which ball has more tendency to maintain the motion? Okay, when you motionless, which ball has the more tendency to remain the motionless when you try to throw it in the air? Okay, when you try to kick it or when you try to throw it, and then which ball has the more tendency to keep its state of rest? And second question can be the which ball is more likely to keep moving when you try to catch it. Okay, these are the two ball. One is the basketball and other one is the bowling ball. Bowling ball is the heavier than the basketball, as basketball has less mass as compared to the bowling ball. That's why it has the more inertia. Here the inertia means that what mean by inertia? Here inertia means that it is the tendency of the body to resist in its change, as we have already discussed this point in our Newton first law of the motion. Because so as this has the more inertia and this one has the less inertia. So this ball has the basketball has the less inertia, and it has more inertia, it has the less mass, and it has the more mass. And so when this ball has the less mass and less inertia, so this basketball will keep moving when you try to catch it. It will cover a large distance as compared to this ball. It has the more inertia, so it is the more resistance to change in its velocity. So when you try to throw the ball, so this ball will try to remain the motionless because it resists its change harder than the basketball. Okay. Now what is the mass? So now what is the mass? We can define the mass. And here, what is mass? So we can define here, we can define the mass. We can say that it is the property of the object that which specifies how much inertia the object has. So this is property of an object. It is internal property of object. It is the property of the object which defines how much inertia object has. So it defines the object inertia. And more about the is the mass is that unit of mass. What are the unit of mass? How we can measure the mass? So the most famous unit, SI unit systems, the unit of mass are kilogram. So the SI units of the mass are kilogram, and you can measure it in the unit of kilogram. So greater the mass of an object, less the object accelerate under the action of force. Okay, it is harder to accelerate the object if it has a larger mass. For example, let's suppose we have an example. You have the two masses. Let's suppose this mass, we suppose that this is of 3 kg, and let's suppose we have another mass that is of 6 kg. Okay, this object has larger mass as compared to this one. Okay, now if we apply the force on the mass of 3 kg object, so it will produce, let's suppose it produce an acceleration of in the object that is of 4 meter per second square. Okay, now the force of the same magnitude, we apply the force of same magnitude on the object of 6 kg object, then it will produce an acceleration of 2 meter per second square. Now as here we have seen that if the mass of an object is larger, then it is less likely to accelerate it. So the acceleration will be smaller when the mass is larger. Okay, let's suppose that given forces produces a different acceleration on the different object. It produces an acceleration of a1 on object of mass m1, and the same force will produce, let's suppose it's acceleration a2 on an object of mass m2. So now we can equate the ratio of acceleration to the ratio of masses. So I can write it like the ratio of two masses is inverse the ratio of two acceleration. So I can write it like m1 divided by m2. It will be equal to a2 divided by a1. So the ratio of masses is inversely proportional to the ratio of acceleration. So if an object if for example, if the mass of object is known, then the mass of other objects can be determined from the acceleration measurement. Okay, so we can define the mass. We can say that the mass is inherent property of an object. It's internal property. So mass is inherent property or internal property of an object. Property of an object. And it's an independent of object surrounding. Independent of object surrounding. So it doesn't depends on the location or surrounding of an object. So the mass of object will remain the same, either you mirror it on the surface, on the earth's surface, or you go to the moon and mirror the mass of an object on the moon. The mass will remain the same because it is inherent or internal property of an object. So another thing about the mass is that the mass is a scalar. So it is the scalar, and we can apply the general rules of the mathematics, general rule of arithmetics, in order to measure the masses. Suppose we have the two different masses. Let's suppose one mass is of 3 kg and other mass is of 5 kg. We can combine by simple addition, and so their combined mass will be of 8 kg, and you can verify the results by comparing the acceleration of individual masses. You can find the acceleration of mass of 3 kg, and then applying the same force you can measure the acceleration of 5 kg object, and then you can apply the same force to measure the for object of combined mass to find the acceleration of combined mass. So you can compare the acceleration to verify the results. So now another important thing about is that what is difference between the weight and mass. So now the difference between mass and weight. What is difference between them? Most of the people get confused, always confused with the mass and the weight. So the mass should not be confused with the weight. Both are totally different quantities. The mass, I have already told you that mass is the internal property of an object. It is internal property of an object. Okay, and it's independent of the surrounding. It doesn't depends on the surrounding. On the other hand, the weight. What is the weight? Weight, it is the magnitude of the gravitational force. So we can define the weight. It is equal to the magnitude of gravitational force. So it is equal to the magnitude of gravitational force, that is equal to mg. So it depends on the location of an object. So we can say that it varies with the location. Varies with location. As the mass, which is the inherent property or internal property of the object, it doesn't depend on the surrounding or location of the object, and it remains the same at every place. Rather, the weight which is equal to the magnitude of gravitational force. As the magnitude of the gravitational force is depends it varies with the location from the center of the earth. So the weight of the object or weight of the body also varies with the location. For example, object of the same mass whose weight varies between, like the it is, for example, if an object, if you have the object of same mass, the mass of object is the same, but its weight is, for example, it's 180 pound on earth surface. If you measure its weight, it will be the 180 pound on the earth surface. But when you go to the moon, when you go to the moon, then at moon surface, the object mass is the same, but now its weight it reduced to, for example, I say that it is 30 pound. Now the same object has the weight of 30 pound on the moon and 180 pound on the earth surface. So on the other hand, the mass of the body remains the same, either it is on the earth surface or it is either you measure it on the moon. So this was all about mass, concept of the mass. Okay, thanks for watching. For more videos, please subscribe our channel.